Hey guys, welcome to question FM345 of the Further Maths Fortify study guide. This question reads, to practice for the Olympics, Braden runs a lane at a practice track with a straight length of 80 meters, internal radius of 37.7 meters, and a lane width of 1 meter as shown in the figure below. And then we're given a figure that looks somewhat like this. Then goes on to say, assume that Braden runs in the perfect middle of the lane shown by the dotted path in the above figure. Now I haven't put the dotted path in, but you guys will have that in your books. Part A says, show that the distance that Braden runs in a single lap is 400 meters correct to the nearest meter. Now what we know about this shape is that it is made up of a straight line, and then a semicircle, and a semicircle. So effectively what we have is two straights and a full circle, and that's how we're going to show this question. So we're going to show that we have a circle plus two straights. So the first thing we're going to do is show that the area of the circle. So the circle, to find the circumference of this circle, which would show us the length that he runs, the formula would be 2 pi r. Now r in this case is not going to be equal to 37.7, it's actually going to be equal to 37.7 plus 0.5, because remember that this lane is also a meter wide and he's running in the middle. So we've got to add half a meter to that amount, which will land us at 38.2 meters. Substituting that back in for our circle, we get a value for our circle of 2 times pi times 38.2. Our straights, they're pretty straightforward. They're just going to be 80 meters each. Whacking this all together, we should get 2 times pi times 38.2 plus 2 times 80. Whacking that all into a calculator and then writing it correct to the nearest meter, we should get 400 meters, and there is our little show that. Before starting question B, or part B, we're given a little more information once again. This time we're told that the entire track of 3 lanes is shown below. Now my drawing here is awful, so lean a lot on your diagram in your book, but you should get the idea. Each extra lane is an additional 1 meter further from the inside lane. The starting positions of each additional lane will be further down the lane to keep the lap distance the same, so that each lane finishes at the same finish line. So effectively, they'll start the inside lane here. They'll probably start the second lane somewhere out there, and then the third lane here. That way, each of them is having to run 400 meters, and no one is getting any advantage. Question B says, if Braden starts running in the outer lane, as shown by the start point, what is the angle theta in degrees that is required for Braden to run the same lap length as the inner lane? Round your answer to the nearest degree. So first of all, what we know about this shape is that, once again, it's going to be made up of parts of a circle, so not a full semicircle, just under. So we're obviously going to be missing that angle difference that we're looking for here. It's going to be made up of another straight, another full semicircle, and another straight. Now, altogether, this distance should be 400 meters, which means that if we remove the 2 straights so that we're just left with this portion of the circle that we're looking at, we should be able to remove 2 lots of 80, which means that we're only dealing now with 240 meters for the circumference of, well, not the circumference of, but the arc length of this partial circle. So to redraw this circle so that it's maybe a little bit more intuitive to what's going on here, we're going to have a circle that kind of looks like this, and this little portion that's being cut out of it, this little angle is going to be that same angle that we're looking for up there. So if we can find this angle, let's call it alpha, and subtract that from 360, we should be in business. So our arc formula is equal to, now I'm going to do sort of a more extended out one, which is 2 pi r times, I'm not going to write alpha times theta over 360. So this is just saying that if you've got a full circumference for a full circle, we only want this degree out of the full 360. So we only want this alpha portion out of the full 360. We know that our arc length is going to be 240 meters. We know that our radius is going to be 37.7 plus, we're going to have to go 1 meter, 2 meters, and then half meter to get to that outside lane. So we're going to add 2.5, which means that our radius is actually going to be 40.2 meters. Putting this all back into our original equation up here, or our original formula up here, we should get the equation 240 is equal to 2 times pi times 40.2 times alpha over 360. At this point, solve is a good idea, and you're going to solve for this value of alpha. Alpha should come back as being 342.06 degrees when we round it to 2 decimal places. From here, like we said before, 360 minus alpha should equal theta. So theta equals 360 minus 342.06, which means theta, when rounded to the nearest whole degree, should be equal to 18 degrees. If you guys have any questions about the questions we've just done, please leave them in the comments below. Otherwise, I will see you in the next video.